What's up, everybody? So today we're going to work on another lab machine here, and the lab machine name is Pandoras Box. So let's go ahead and check this out. So the difficulty level is medium, and it says Pandoras Box is a boot-to-root VM focused on binary exploitation, and reverse engineering. You have to complete all levels to root the box. Some levels come with a README file, which you should read. Let's see, usage, import boot, wait 60 seconds for everything to start up, and for scanning. Alright, so as you can see here, I already have the box loaded up. So let's just jump right into it. Let's get a terminal loaded. And let's clear our screen here. And first thing first, let's do some enumeration. So let's find the IP of the server, do an ARP scan, and because I know my network, I know that that 150 IP is going to be the new server. Let's go ahead and do a quick scan and see if there's anything open. So we got SSH open, but we don't have any sort of credentials to attempt to use or any sort of private keys or anything like that. So, Alright, let's try a deeper scan. See if we can come up with anything else. Let's see. What did I do wrong? There we go. I'm just going to go ahead and let this run. I'm going to pause the video and unpause when it's finished. Okay, the scan is complete. So it looks like we do have some other ports available, 53121 and 54311. So let's go ahead and connect to those and see what's going on those ports. So let's go with 53121. Notes manager. Type help for command list. So this looks like some sort of text editor. Interesting. So I'm going to speculate that this program is probably vulnerable to some sort of bug, and we're going to need to exploit it. Let's check out the other port, 54311. Hey. Secure remote shell. Please log in with password. Let's try no password. Nope. Let's try password. Oh, that's interesting. It shows our password as we type it. Secret. Nope. God. Sex. Money. Admin. Root. Tour. This is cool. So it doesn't seem to limit the amount of passwords we can try. So we could try a brute force attack. So that's a possibility. Let's go back to this one and see what we can do. Alright, so we got a new node. So I guess maybe now we set 0 text 32 max. Huh. If that's not a clue, I don't know what is. So I bet it's saying that you can enter in a node that's only up to 32 characters. So I bet it's vulnerable to a buffer overflow. So let's try. So it's 32. Let's try 33. That seemed to work. Which ID was that? 0. Yep, that worked. Let's try more. That looks promising. Invalid command. Invalid command, try help. Let's see, so delete show set new. So show 1, yep, that doesn't exist. Oh, that's weird. Let's try an even bigger buffer. Doesn't seem to have done anything. Oh, that's interesting. So we can see that we are overwriting some part of the buffer. So let's create another one and see if the X's show up. Nope, none there, but maybe we just didn't overwrite enough. So let's set 0. Let's see if try A's. And if it's doing what I think it's doing, these other ones, other notes, should display some A characters. So let's do show 1. Oh, we made it crash. That's a good sign. So let's do show 2. 2 doesn't exist. So show 1. 1 doesn't exist. Oh yeah, we made it crash. So what's going on? Oh yeah. Reset 0. Oh, but how much? So let's see. It's 3264. Let's do 3 times. Now let's new show 1. Aha, see, some of our X's spilled over. So let's do set 0, 32, 64, 96, 128. So we'll show. This time we'll do number 1. Yep, cause it to crash. Crap. So set 0, 1, 2, 3, 4. Let's back up 8. 1, 2, 3, 4, 5, 6, 7, 8. Show 0. New show 1. And valid command. So set 0. 1, 2, 3, 4. Let's go back to the login SSH. Let's play with that some. So let's try a really long password. See if there's a buffer overflow. Nope, that didn't work. I wonder if possibly this is vulnerable to a timing attack. And why don't we go ahead and see what a timing attack is all about. In cryptography, a timing attack is a side-channel attack in which the attacker attempts to compromise a crypto system by analyzing the time taken to execute cryptographic algorithms. Every logical operation a computer takes time to execute, and the time can differ based on the input. With precise measurements of the time for each operation, an attacker can work backwards to the input. So basically what it's saying is that it can take a different amount of time to process a correct answer as compared to an incorrect answer. So by knowing this and then using a brute force attack, we can then work backwards to figure out what the password is. So basically what we would do is we would take the ASCII chart, basically characters of the alphabet and other characters available to us on a keyboard, and then send each character to the login prompt and then time it how long it takes to respond back with a yes or a no, basically. Well, actually, it wouldn't be a yes or no, because most likely the password's not going to be just one character. But what it'll have to do is whenever we send, for example, the character A, the server will read that, it will encrypt that, compare that with the password, and then tell you if the password was correct. It will then give you a shell. If not, it will tell you something like invalid password. Now, if you entered in the letter B and that happened to be the first letter of the password, the amount of time it would take to create the basically the hash and compare would be less. So in theory, you could compare the time for each character, and the character with the least amount of process time very well could be the character for the password. And then by stacking these characters that you find and repeating this process, you can then discover the password. So I know this is probably very difficult to visualize, so let's just get into it and start testing it out and see if this will work. Alright, so we're going to write some code, and this will help us determine if we can exploit this vulnerability, and it might not even exist in this, I don't know, so we'll see. Alright, so let's write, I need some music, get some music going. Alright, so let's go ahead and write a Python script. Let's call it pastime. That's kind of what we're doing. Alright. So we're going to need to use some sockets because we're going to need to send some data to the server. This is going to be Pandora. What was that port? I think it was 54311. We'll check that. Now we need the characters that we want to try for the password. So let's just start with the did I get that right? Yeah. And then the numbers. Alright, we'll do that, and if we now find it with that, we'll add in all the other characters like, you know, quotes and semicolons, etc., etc. So we'll use that for now. Alright, so now we need to open our socket. Then we will connect to the server on the port. So So for each character in our list of characters, so what we need to do is we need to connect to the SSH server, and before we send the password, start keeping track of time, send the password, and then see how long it took to get a response back, and print that to the screen, and do that for every character. Alright, so let's create a function that will handle the sending of the data to the server. It's going to send a character. So we need to start tracking time. So start a loop. This will be our packet from the server. Let's do 1024. So whenever we get a response from the server, we'll put it into the packet variable. And then we'll check to see if we're at a password prompt, because that's what it was showing, was just a password prompt. So if password in, so basically if the text password is in the packet, then do this. We'll send our character, so I'll do send character, and then we'll get our elapsed time. And then we'll break. And then we'll return the time, which will be E time, subtract S time. And just return that. I think that'll work. So then what we need to do is you're going to loop through each character. So we'll get the elapsed time from send data. Actually, let's name that get time. So that's what it's doing. And then we will print to the screen that we are working with character. Let's see. Elapsed time. I think that's about it. I need to close our socket. Alright, I think we got it. Let's see. Let me look over it real quick for any problems. Make sure the alphabet's right. I think we're all right. Why do I have a break there? Oh yeah, for my while loop. Alright, let's try this. So what I need is pastime. Alright, so I need to make it executable. Now we can execute it. And we have an error. It looks like a typo. Yeah. Let's try it again. Alright, so if you look here, you can see it connected to the server, sent the letter across, and gave us a time for how long it took to respond, which you can see it responds pretty fast. And then it went to letter B and repeated this process and just kept doing this for each letter and recording the time. And if you look, the times are pretty close to one another. They're not far off. And what we want to do is we want to look for one that is significantly less than the others. Like this S might be one. Just look at that. It is much faster than all these other ones. Something's off though. Those don't seem like they should be taking that much longer. I think there's something wrong here. But so is the letter A. It's much slower. Oh, hold on. I think the first one is junk. Let's see. While true, packet received. Let's try this. Yeah, because I don't think it's going to work the first time. So I think we need to account for that. So let's run this again. Broke something. Uh-oh. Should fix that. Alright, there we go. So let's run that again and let's grab and see which ones. I think let's see. So most of them are 0, 0. So let's look for how many are. So we're only getting one. So potentially the first letter of the password could be R. If we got everything lined up properly. I was showing S before, but I think that was because the first one was no good, so I was throwing it off one. And this is showing to be the fastest. Let's make sure. Let's see. Yeah, we're not finding any that are faster. Yeah. Oh, shit. hold on. No, it's still R. I don't know why it showed that other one. Alright, so let's expand on this code a little bit. Alright, so let's modify the code so it'll spit out the lowest or the fastest character, which theoretically should be the correct character for the password. So, what do we need to do? Let's do it like, let's see. So we're going to need a minimum. Start at number 1. This will be our minimum value or our fastest value. This will be the index of the character. So we can keep track of that. We need to keep track as we're looping. So we'll need to do -1 because that first one's no good. So we'll do that. Then do that. Increment our x value if elapse is less than min. Min equals elapsed, and our index equals x. Yeah. And we'll print password. Then characters index. Alright, so what this should do now is basically it'll automatically go through each letter of the alphabet, get the times for all of them, go through the list and find the fastest time and spit that out to us, and that should be the first letter of the password. And if it's the same as before, it should be the capital R. So let's see what happens. Stop. Give it a second to run. Maybe I screwed something up. Yeah, I think I screwed something up. Yeah, what did I do? Let's see. Oh, what the hell? For one, I got freaking semicolons. I write a lot of C code, so that's where the semicolons are coming from. Let's try this again. I really screwed something up. Let's see. And I found. What did I do? Any more semicolons anywhere? No. sure. Let's see. There we go. I don't know why it wasn't running. So it's saying password S. Crap. So is it R or is it S? What's happened to my terminal? I don't know what's been doing this. Let's see. Alright. Yeah, S. Oh, do we need it? I think we need to do our index by one more. Let's do 2. Alright, now let's try. Alright, I think that's going to be right. I think we'll try both ways, and hopefully the password is a password that's English readable, and we can discern it like that. So let's expand upon our code to continue to do this until basically we guess the password and it logs us in. Alright, so what do we need to do now? Do some more looping. So let's get another function going. Alright, so I need to add that to the beginning. We're not going to print here. That's not going to happen here. So with the elapsed time. Actually, I don't think we're going to need the X here either. So we're going to go through each one. Oh no, we do need the X. What am I thinking? So, oops. Oh crap. I'm screwing shit up. think that's good. Let's create a variable for a password. And then we'll just start looping through with no regard for it just actually stop. That's alright. So then what we need to do is password equals password plus get password. Alright, so let me look back through this before we go over it. Make sure it all looks good. Alright, so hold on. Let's see. So we'll show our progress, that way we can actually see the password as it's being cracked. Then calculate the elapsed time, return that. So I will call get letter, start out with nothing, go through here. Let's see. Yeah, it'll get them in. And it's going to return the character at the fastest time. That'll get added to the password variable. It'll repeat. I'll pass it. And I'll add that letter. Repeat the process. Okay, I think we're good. Okay, so what's going to happen is and so actually when we run this program, it's actually going to start up here and it'll load our imports. We're going to set the server value to our server that we're trying to get into, which is Pandora. This is the port that the SSH program was running on. This is just a list of all the characters that we're going to try for passwords. We're going to create a socket. We're going to create a connection through that socket to our server on that port. This is a function that's not going to run yet. This is another function not going to run yet. We're going to come down here. It's going to create a variable for a password. And we're going to start an infinite loop. And it's going to run the get letter, which is going to come up here, set some variables, start going through each one of these characters in a loop. So then we're going to get the time. And that's going to go through here, put in the letter, see how long it took, and return that back. And this one, we'll then compare it, and if it's the new fastest, we'll add it to the index, and then return that. And we'll just keep doing that until eventually we should have the password. So let's give it a go. Huh. That is looking good. Respect your administrator like your respect. Yeah, boom, boom, boom. Got it. Logged in successfully. So what is the password? It is respect your administrator like your respect. Hold on. Like you respect your God. Okay, so this is the password right here. So boom, yeah, so basically by tracking how long it took the server to respond each time we entered in these various characters, we were basically able to determine which was a correct letter, or character rather, and which one was not. To me, it's kind of like when you see those guys in movies picklocking a safe. I guess I don't know if picklocking would be the correct term, but they have the stethoscope and they're listening for the little click as they're turning the. Again, I don't know the proper word for this. Tumbler is what comes to mind. Listening for it as it clicks over a little point, and they know that aha, this is one of the numbers in the key. So I kind of liken that to this. So anyways, let's go ahead and try this. So we're going to copy this, and unfortunately our code doesn't have any input-output handling, so it's not going to be able to send the commands to the server and get stuff back, even though it says here that we have a shell. Let's confirm that. So let's connect to our server we're trying to get into on that port 150, and that was 54311. And I'll paste our long password and hit enter, and if it is all good, it should let us in. Alright, so let's check our ID. Boom. So we are into the server as level 1. So now we need to try to level up to level 2. So let's start doing some looking around. Let's see, where are we? We're in the home directory. So let's go ahead and back out of there. Let's see if we see any other directories in here. Hey, look at that. Level 2, and what do we see there? A level 2 README file. And it did tell us to read the README files. Let's go ahead and take a look at that. I start this level with this command and use netcat or whatever to communicate with it. Have fun. Alright, perfect guys. So I think this is a good stopping point. We're about an hour in. We just got to level 2. So I'm going to go ahead and pause here, and I'll pick up with level 2 on the next video. Don't forget to like and subscribe, and thanks for watching, and I will see you on the other side.